Hi. So last time we talked about QoS. So I have a video here recorded, and so let's continue to talk about QoS, and let's refresh our memory. So from this article, we wanted to do ingress shaping. So what this article does is it mirrors the ingress packet to your physical interface to a eBPF virtual interface. Then we do the egress shaping, so it converts the ingress from the physical interface to a virtual interface eBPF as egress. So, and this article talks about that, and it has a script to set that up, and also use IP tables. Use IP tables to set a mark on the packet that is sent from this source IP address subnet, right? So, for example, if you want to do traffic shaping upload limit from those users or servers from the router point of view, the upload traffic is ingress, right? So by default, the TC do not do ingress shaping. It can do egress shaping. So you need to have a mirror set up to mirror the ingress to egress, so we can do TC shaping. Also, in your router, you have to do a source address translation, right? And so all the IP addresses from your internal network is translated to your IP address on the internet-facing interface. So it is going to be a challenge to do ingress shaping for the internal networks, and right. And also, so that the way it works, workaround is to set up IP tables to set up mark on all those packets sending from the internal network, and so it can recognize those packets when it can recognize those packets to do the ingress shaping. But we don't want to do that. Since we have BPF program, we can replace the IP tables set mark function with BPF program, and we have the BPF program here again under my GitHub repo, TC base classifier with class TC base this BPF program, and so we can filter based on the IP, and yeah, we can basically just store the internal network source IP in this BPF or IP try map, and then when the packet when the BPF program process the packet, we can check if the source IP address is in the BPF map. If it is in the BPF map, we have a class ID. We have a IP class, TC class assigned to the IP, and then we can do the traffic shaping for ingress. So for diagram here, I draw a diagram. So this is a slightly adjusted diagram. Now we attach the BPF program to the green 0 interface. Remember when we do egress shaping, we attach the BPF program to the red 0 interface. Like in this case for our open source firewall, when we do egress traffic shaping based on TCP port, we attach the BPF program to the red 0 interface, because in this direction, the traffic is egress direction. But now we want to do ingress shaping, so the packet from this internal network, it first arrives to the green 0 interface, so that's the ingress direction, right? So we want to do ingress traffic shaping, we needed to attach BPF program to the internal network interface, the green 0 interface. But the TC cannot do ingress traffic shaping, so we have to mirror all the ingress traffic to the virtual interface if B0, and then all the ingress traffic becomes egress traffic. Then we can do similar TC egress traffic shaping like the red 0, right? So we set up a TC class, egress class on this virtual interface. So that's how it works, and we can, based on do the traffic shaping based on the internal source IP, or based on the TCP port or UDP port. So let's do the demonstration. And so this is our open source firewall. We have this class filter program, and so we can run class filter dash I. Actually, I don't remember the let me log into my development server. Okay, I can look up here from the commit message. We have commit here. I add TC. Where's my TC? Oh, yeah, it's in the okay. It's not here. Oh, it's in the. It's not here. In my repo, LoongFire. Let's look at this here. Oh, this is all included in the. So this is a commit. This is a class filter program. I added here. So this is a syntax. This is a command syntax argument we can run. So let's go to our open source firewall. Class filter. So here again, we run this program, specify the interface green 0. So which means is we want mirror the traffic, the ingress traffic from the to the green 0 interface to a virtual interface ifb0. Okay, and we set up. This is the setup for the -3. The bandwidth is for the default read limit. So let's set up the default with 50 megabit per second, and so those is this -A is to attach the program, -I is to set up the mirror. Okay, here it has the help message. -I set up ifb mirroring, set up the virtual interface for ingress. -A is to attach BPF program to interface. -I is the physical network interface. Okay, so let's run. So now we set up everything. We can let's check if we have the mirror interface set up. So we have ifb0 set up, which is to mirror all the ingress traffic of this green 0 interface. Okay. So okay. So now let's look at the help message again. Now if we let's do a test. So we set up the default is 50 megabit per second, right? So let's run this. Remember we send it from this iPerf client, internal iPerf client, to outside internet iPerf server with all this TCP port listening. And we have default bandwidth set to 50 megabit per second. So it should be around 50 megabit per second. Okay, so it's around 50 megabit per second. The setup is working for the default. Now let's set up the. So this client we have this iPerf client. We have the internal IP address is 913, right? So now we wanted to traffic shaping for this internal source IP. Let's limit it to 30 megabit or 40 megabit. We can set up now. We can set up -R. First, we needed to specify the interface. Now we needed to set up the interface ifb0 because the BPF program is attached to ifb0 interface, and with -R to specify the source IP. So with a syntax similar like this, right? Let's change our source IP address 13. We only want to limit to this source IP, and the class we can give a class ID 40 and limit it to 30 megabit per second. Okay, now the class is set up 30 megabit per second. Source IP is mapped to this class 40. Okay, now let's test. From this client, previously we have a default 50 megabit, right? Now it should be about 30 megabits. Okay, so it is around 30 megabit. So it works for traffic shaping based on source IP, right? Now we also wanted to know if we want to do traffic shaping for ingress based on the TCP port number. And would it work? Let's see. We needed to set up let's say dash I. Let's again if b0 and dash p is to add a port. And we have this port here, syntax like this. And let's say we want to limit port 8080 to 882 with class ID 20 and limit it to, let's say, 8 megabit per second. Okay? Okay, now it's set up. And let's do the test now. I think we may need to remove the source shaping because, let's see, because because it's the IP traffic shaping take priority over the TCP port. So let's see. I think it will. Okay, let's go to port 80. I think it will still be 30, right? Because we still have the source IP based traffic shaping set up. So we need to remove that. Remove this. So dash X is to remove. Remove the source IP. To remove, we don't need. We just give the source IP. So now it's moved. We can double check. We can double check with dash M to list IP. So there is no record in the BPF map, but we can use dash L to list the port. We have the port. So this 3 TCP port is mapped to class ID 20. Should have limit to let's limit to 80 megabit per second. So now we test. Should be 80 megabit per second. Okay, around 80, right? Yeah. So it works. And so let's go back to this article. So this article is that with IP tables, you needed to set up this, you needed to have all these IP tables set up. And then if you want a different source IP, you have for ingress shaping, you needed to set up all IP table rules for this different source IP. With BPF, we save that trouble. We just set up this BPF mapping, and it does the work, right? Like, let's add it again. Like if we do it, add the source IP again, and we ammo. So we have the BPF mapping here for the source IP and the TC class ID, and then we have for this class ID we have 30 megabit limit. TC TC class show def, I think it's -g show def if be 0. So we can see the hierarchy of TC class setup, right? So we have the class ID 40. Class ID 40, it's based on the source IP, and class ID 20. Class ID 20 is for the TCP port. Class -L. So class ID 20 for the TCP port. This 3 TCP port. 30 is the default class, which is 50 megabit, right? So this is easy to set up, and just with this single program. Okay? Yeah, so I hope I explained it clearly, and yeah, thanks for watching.